From sparking creativity to transforming how we communicate discovery, the intersection of art and science is unlocking new possibilities in research and innovation. Here in Washington, D.C., the American Geophysical Union is showcasing how creativity and science work hand in hand to shape the future of Earth and space exploration. This is AGU 24, and you're watching AGU TV. Welcome back to AGU 24. I'm your host, Rachel Phillips, and today we're exploring the exciting intersection of art and science. Through inspiring conversations and innovative projects, we'll uncover how creativity is enhancing scientific discovery and communication. From groundbreaking collaborations to artistic approaches that bring science to life, AGU 24 is highlighting why art and science are stronger together. And here at AGU TV, we're diving into what's next for this transformative partnership. Today, we focus on the powerful connection between art and science and its transformative impact on research and communication. Integrating creativity with scientific discovery drives innovation, fosters new perspectives, and opens pathways for deeper understanding and collaboration. We will speak with Rudy Molinek, host of the Under Our Feet podcast, about how communicating science is crucial and finding new ways to do so is so important for moving our field forward.
The key thing there is to remember who science is for.
Mary Alice Yakutchik will speak to us about her incredible Haiku project aboard the JOIDES Resolution research vessel and how science can be communicated through poem.
The last haiku is, your loveliest lines lie left under layers in faults, slips, and failures.
Then we'll talk to you and find out what's next for science. You can catch the latest episode of AGU TV at the Walter E. Washington Convention Center, in your hotel room at the Marriott Marquis DC on Channel 42, on the AGU 24 meeting website, on the AGU 24 mobile app, and of course on all our social media platforms. And while you're there, make sure to subscribe to stay up to date on all of our geophysical content. I am joined by Mary Alice Yakutchik, an editor and writer at Johns Hopkins University, to discuss her incredible haiku project aboard the JOIDES Resolution research vessel. Mary Alice shares how this unique blend of art and science came to life and the ways it enriched the scientific research carried out on the ship. Mary Alice, thank you so much for being here.
Thank you for having me, Rachel. It's my pleasure.
Can you tell us about your experience working on the incredible haiku project aboard the JR and kind of how the project came to be and how you think it enriched the science that was done on the ship?
Yeah, I am a lifelong career journalist and applied out of the blue for a position as an onboard outreach officer aboard the JOIDES Resolution. They put out calls to people of all different kinds of professions and levels of expertise. And so onboard outreach officers require a week of training before we go on the ship. And when I first encountered what a core is, what the JOIDES does is drill deep down under the ocean to bring up core samples from the Pleistocene, from the Cretaceous. The idea came to mind that perhaps we could describe one entire whole which constituted 68 segments of core. So these 68 sediment cores are basically a picture of time that goes back 70 million years. Wow. And each segment of the core, of course, goes farther back. Mm-hmm. So I asked the scientists aboard the ship, there were 30 members of the science party, if they would be game to each take one segment of a core that spoke to them, that somehow intrigued them, and describe it in 17 syllables in 3 lines, a haiku. And they were like, huh?
Naturally, as scientists would.
As a scientist would. And the other reaction was, I'm not a poet. Like, it was sheer terror, and it was like, are you crazy?
I can analyze the chemicals, but I can't write a haiku.
Right, exactly. Yeah, that's not my level of expertise.
Yeah, that's incredible. And you brought today the haiku illustrated book.
I did.
From this project.
Bring the haiku illustrated book from the project. The International Ocean Discovery Program was kind enough to publish. I collaborated with a visual artist who was also an onboard outreach officer. Marlo Garnsworthy did amazing watercolors that complement each haiku. I think there were 68 cores, but there are 70 haiku. One kind of is a little prelude and one ends things up. So it's a series of haiku, again, that represents a collaborative effort by the scientists on the JOIDES to describe the whole of one whole.
Wow, that is really incredible. Can you read one?
I would love to. Speaking of the whole, there is a haiku that begins, "A whole is a whole, book of time to be savored, past informs future."
I love that one. I love just the science behind the poems in here are, I mean, they all work and they all kind of tell the story through time as you go through the core, and you hear each one is kind of a new segment. It's a new, scientific concept, but they're all told in such a short little clip so well in the scientific story of it. So I think that's really incredible, and I have just got the pleasure to look through this morning, and it's just really, really incredible what came together from this. So I applaud this effort.
Thank you. Some are very literal of what a scientist saw or touched or smelled, and some are incredibly esoteric. The last haiku is, "Your loveliest lines lie left under layers in faults, slips, and failures." And that particular haiku is about the core that we didn't get. It's the core that was at the very bottom of our,
Wow. Those are all so beautiful and so meaningful. And I hope that this work will inspire other geoscientists to also incorporate some sort of project like this into their work. I think it's so important that we integrate the arts and sciences in this way. You've already inspired me to go out and try and share my work differently, so thank you for that, and thank you for coming on and sharing this.
Thank you, Rachel. It's been a pleasure.
Geosciences plays a very critical role in energy transition. We use geosciences to identify sustainable energy resources like geothermal energy, critical minerals, hydrogen. We also need to understand geology to be able to store CO2 underground safely to mitigate climate change. And last, we need to understand the principles of geosciences to understand the environmental impacts of energy development. My lab is called ISO-BioGem Lab. Our focus is primarily on developing technologies in sustainable energy.
My experience in the ISO-BioGem Lab has led me to an interdisciplinary, multidimensional take on renewable energy research, and has really developed myself as a young career researcher.
They're actually doing field work, they're working with industry, they're working at national labs. That really is great career preparation for them.
When all of us can work collectively, we'll be able to solve the energy challenges that are ahead of us in the future.
I am joined by Dr. M.J. Riches, an NSF postdoctoral research fellow in the Farmer Lab at Colorado State University. With unique background in blending art and science, Dr. Riches is here to share insights on how this powerful intersection is evolving, fostering creativity in research, and opening new pathways for discovery and collaboration. Dr. Riches, thank you so much for being here.
I'm excited to be here.
So when AGU first introduced kind of the arts and sciences sessions, there was certainly some skeptics. what has been your point of view as you've seen this landscape kind of change over time?
So within the past 5 years particularly, it's been a really amazing shift. When I first started coming to AGU, the science parts of it were always well attended, but the art parts were really well attended mostly by early career scientists.
Yeah.
Since then, I've seen a remarkable shift. Now we have more senior scientists coming, and here they are doing the science art, not just for the fun of doing science art in the middle of AGU, which is fun, but also to learn something and learn a few things. I've had folks reach out to me afterwards saying that they were able to include some of what they learned in their classes or in their grants.
Oh, that's incredible. Yeah, as somebody who's really passionate about science communication, I find more and more as I try to convey concepts to the general public or to lay audiences that visuals and art is so important in that. And as we kind of move forward, we're living in uncertain times with the new administration taking office. So with that, what concerns you and where are you looking for areas of possible common ground that maybe the arts can help propel?
I think a lot concerns me. As an early career researcher, especially the question of where's the next paycheck coming from. So many of us are interested in positions where the future is uncertain. So I think as early career folks in particular are kind of like eyeing back and forth. But what also concerns me is misinformation and mistrust. And I think that's particularly where science art comes from. I think a lot of folks understand the power of science art to communicate scientific messages, but science art can also communicate our humanity. I think it's important for the general public, which we're also a part of, but for the general public to really understand that not only are we humans, we have a say, we have a need for the future. We have hobbies, families, properties, all at risk with climate change. And so from that common ground perspective, I'm as concerned as the folks who live on the coast are. And I think using science art to convey that humility, to convey that humanity, to make it clear what I'm interested in outside of the science and make us less fearful.
Yeah, absolutely. And with that, what do you think is next for art and science? Or where do you think art can take science next? And where do you think science can take art?
So I've thought a lot about this, and I remember my childhood, and I think so many of us get to grow up on like visuals, right? So we start reading picture books for fun, reading comics. And I think that visual aspect then has been ingrained into us. It's fun, it's how so many of us start learning languages and learning creativity, be it the very hungry caterpillar or cat in a hat. And I think that instills then the power of visuals. Even to this day, science art can take and bring that art into the scientific field to help convey what science really means. And that's where the literacy comes in from scientific literacy and using art to kind of build that. From a science perspective, there's a few things we can do. We can reach out to artists to help build those relationships, to help share our science. Science artists can really only do as much as they know scientifically, and reading papers is great, but hearing directly from scientists is even more powerful. And I think at the end of the day, whether it's through grant funding or through these kinds of communications, having as a scientist that desire to learn about science art. If you're in a position to encourage your colleagues, to encourage your group to have some amount of experience firsthand with science communication. I'm biased towards art, but science communication as a whole, I think that's really powerful. We aren't trained in this, but we're expected to know it. And so really trying firsthand will gain that experience and that appreciation.
Yeah, absolutely. And I love what you said about building relationships. That's a common thing we've heard over and over again with these interviews is whatever the topic, building relationships is the first step to really build whatever the intersection that we're trying to build is. And with science and art, that is a really important thing for us to reach out to the artists and have those conversations. So thank you so much for coming on and sharing all this.
Thank you for having me.
Citizen CATE 2024 was a mission to observe the total solar eclipse that happened over the United States on April 8th, 2024. The eclipse passed over a large swath of the United States, from Texas through the Midwest all the way up into Maine, spending almost an hour of totality over the United States. We wanted to study the outer atmosphere of the sun, the solar corona.
We have two overarching goals, one of which is to do some really groundbreaking science. And in order to do that, we're using our community scientists or citizen scientists along the path of totality. The outreach is just as important to us as the sciences.
Projects like CATE are very important because they get not just scientists involved, but the community involved.
But we really hope that they got an experience that they will remember for the rest of their lives, and maybe might even make a difference in a career path or how they look at science in the future.
I am joined by Dr. Roger Turner, Curator of Instruments and Artifacts at the Science History Institute and a renowned historian and storyteller. With expertise in 20th century atmospheric science and the intersection of history and science, Dr. Turner shares his perspective on how creativity and storytelling can propel scientific understanding and inspire the next generation of diverse professionals. Dr. Turner, thank you so much for joining us.
I'm delighted to be here today.
Science has always been propelled by people. So how can we as a scientific community attract and grow the field of geoscience, specifically at the intersection of science and art?
Art is amazing at bridging differences in communities and bringing people together who come from different points of view and different perspectives. And one of the things that I've really enjoyed studying in the history of science is the way that scientists have used art to communicate science to people that needed to learn science but didn't necessarily have the same training or educational backgrounds that the scientists themselves did. One thing I've looked at is the way that meteorologists trained during World War II used comic art to teach meteorology to pilots who needed to understand how to fly and navigate through dangerous weather conditions.
That's so cool. Yeah, I always, I'm really passionate about science communication, and one of the biggest things is visuals. And there's so much art involved with that, and people don't often see that intersection as, really being important or a thing. But, if we're just communicating our science to each other through text and data, what's the use? There's no, value from that. We really have to get it out to people in an understandable way, and visuals are often really important for that, and other versions of art.
So one thing that I love is meteorologists during the war and the U.S. military hired people like artist Eric Sloan to draw cartoons that translated meteorological principles into a technique that he called the thought picture method. So it was basically comics and cartoons that would be readily understood for the pilots and the technicians who read comic books all the time or read comic strips. So here's a great example of a pilot and sort of illustrating how the changing levels of atmospheric pressure affected the oxygen levels in the blood for pilots. And so he did this he was a passionate illustrator of weather and meteorology in many ways.
That is really, really cool. That is, I love that you brought visuals as is appropriate for this talk. So we're obviously living in very dynamic and uncertain times as the new administration takes office. So what concerns you with this, and where are you looking for areas of possible common ground, specifically with regards to arts and science?
I think it's so important that scientists and people in the humanities, people in the arts come together to stand up to support each other and to speak for freedom of speech, for freedom of expression, for freedom to read and study, but also for freedom to govern our own institutions. To me, I'm optimistic, but I think it's just so crucial that we stick together in this, right? We don't retreat to making sure that our own individual disciplines or our own individual departments are all right, but to make sure that we're standing together to sustain our institutions as a whole.
Absolutely. Yeah, standing together and that, interdisciplinary and inclusive way of approaching science these days is one of the things that throughout this week we've heard over and over again. Lastly, where can art take science next, and where can science take art?
Thinking historically, one of the remarkable things that I've enjoyed learning and enjoyed sort of discovering is these hidden connections between science and art. So one thing that grew out of World War II was that meteorologists had, once they had learned that comics and cartoons were an effective way to communicate, they actually brought that out of the military into television. So when the television weather report was basically invented in the years after World War II, many of those first television weathercasters were former military meteorologists who had worked with pilots in the Air Force and the Navy during the war. And they discovered that those same techniques of using cartoons that had been so effective in working with pilots actually translated to television. And so that helped to kind of create the visual style of the television weather report, which in turn helped make the TV weather report probably the most widely consumed and most popular form of science in the United States during the 20th century.
Yeah, wow, that is really incredible. And it's so important, this movement of our intersection between art and science with public engagement and getting more people to not only understand what we're saying in earth and space science, but also engage with it. So with that, thank you so much for coming on and sharing this.
Thank you so much.
New observations have found new sources of pollution in the stratosphere that are linked to climate change. When looking at the problem, scientists landed on the most promising approach to cooling the climate system quickly, stratospheric aerosol interventions.
If you have enough aerosol, it will act as a shield to incoming solar radiation. If hypothetically we put something like that in the model, we do see rapid reduction in the global temperature.
We in Silver Lining worked with scientists and other experts to identify a roadmap of research, understanding the effects of aerosols in the stratosphere and how that affects the climate system.
At Silver Lining, we're observing the stratosphere with more instruments, with greater frequencies and over greater time periods and spatial extents for developing that basic understanding.
We're trying to predict and model the behavior of this aerosol plume that we're looking at. And in order to do that, we have to actually make detailed measurements of the data.
The health of the stratosphere and the ozone layer in particular may depend on our ability to observe and to project the effects of aerosols. This research helps advance everyone's ability to evaluate and share in this knowledge.
I am joined by Rudy Molinek, an award-winning podcaster, writer, and storyteller, as well as a PhD candidate in geoscience at UW-Madison. With expertise spanning sea level change and science communication, Rudy brings a unique perspective on the vital role of sharing science with the broader public and how it can shape the relationship between science and society. Rudy, thanks so much for being here.
Thanks for having me.
So given your background in both scientific research and communication, why do you think it's important that we as a scientific community try and communicate our science to the broader public?
I think that the key thing there is to remember who science is for. Like it's not necessarily for getting grant money or building a nice lab or just, and in some respects sometimes it is for the pure pursuit of knowledge, but really what science is for everyone, for the public. And so communication is vital in bridging that, bringing science to the public, bringing it to the people who it is actually for.
So right now we're obviously living in dynamic times, uncertain futures with the new administration taking office. So with this, how are ways that you are trying to use science communication to promote the continued advancement of science through these times?
Yeah, I mean, I think people want to learn about science more now than ever. I think there's a huge appetite for it out there, and I think it's something that crosses all sorts of divides. I think you can take people who disagree on just about everything. If they live near a park or there's a place that they love, geologists and people working on studying the Earth have figured out something about that place that they'd be interested to learn. And it doesn't matter what else they think outside of that. But I think we're lucky to be in a community of scientists here whose work is about our planet, and I guess other planets too.
That's so true.
But it's something we all share. And so, yeah, I think in uncertain times, like, what's better than connecting to the places around you? And yeah, that's a big goal of mine, is to help people do that.
I love that. Yeah, really understanding where you are, why it's significant. There are so many things that I'll talk to people about and they're like, oh, I didn't know that that's how this got here, you know, and just learning about what you're standing on and where you are and the significance of it is really cool sometimes.
Yeah.
So with looking to the future in science, AGU 24's theme this year is What's Next for Science. So what's your next for science? What are you looking forward to at this meeting?
Yeah, and maybe this sounds a little silly to say at a conference where probably most of the people are looking back in time, but it's pretty amazing to be here around, like, what is the future of science and future of geology. That's I come here from geology, and I know AGU has a lot of other disciplines, but yeah, for a science that thinks about the past, I think the future is looking really cool. I've been loving, all the sessions where there's early career researchers with people who are senior in their field, having conversations through their talks. And so I guess what I'm just looking forward to is, like, seeing what everyone's going to talk about next year.
Yeah.
Based on what I've seen.
Yeah, isn't that fun? Trying to predict that.
Yeah.
And thinking about, what's next for science, specifically around, science communication and our, interactions with the general public. Where do you think society can take science next, and where do you think science can take society?
It's an awesome question, because I think it is a feedback loop. It's a cycle. Like, scientists should be responsive to what broader society is looking for, asking for, but society should be responsive to what scientists are learning. And I think what's fun for me as a science writer, a science communicator, you get to be helping society hear what science is doing, and science see what society is responding to that. So yeah, in this self-centered world I've just created, us science communicators are the ones who are making that wheel go round.
That is awesome. Well, yeah, I think your perspective on this is really cool, given your expertise in both research and your experience, communicating science. How long have you been doing science communication with your podcast and all your other work?
Yeah, I started the podcast, I think, about 3.5 years ago. And it's just sort of, taken off from there.
That's awesome. Well, thank you for all that you do for science communication, connecting science and society. So thank you for that, and thank you for coming on today.
Yeah, thanks for having me here.
Since 2003, we've been helping customers understand the underground with 3D modeling software for geosciences. We partnered with a video game producer called Cerebral Fix to build a completely free tool for educators and students alike to get them immersed in geoscience in a three-dimensional interactive way.
We're often in structural geology looking at maps and cross-sections, which are two-dimensional views of the geological environment. In visible geology, you get to see it in 3 dimensions.
It's really intuitive, it's very easy to use, it's got quite simple controls, and you don't need to spend a lot of time instructing students on how to use it. They can play around with it and figure it out.
And it's kind of a piece of the puzzle that's missing when we look at maps and cross-sections. So we can't always put those together in our heads, but visible geology is a very good way to visualize that.
Hi, I'm Rudy Molinek, the host of the podcast Under Our Feet, and I'm here today with GeoGirl to ask a few questions. So, Rachel, can you tell me a bit about your channel, what you do?
Yeah, so I have a YouTube channel called GeoGirl that I have been posting educational geoscience videos to for over 4 years now. I started during when the pandemic started and I was a teaching assistant in grad school. I started putting lectures up there for my students, and I quickly realized that, my students were the last ones watching those. So yeah, I found that other people were watching them, they were finding them helpful, and I wanted to keep trying to help. And it also was a way that kind of helped me learn about a variety of topics in geoscience, and I really enjoyed it. So I kept doing it. Now it's kind of turned into this big outreach science communication thing on YouTube, and yeah, it's really been really fun. And now it's expanded into, whether it be lectures or interviews or field videos, just all things geology, which is really cool.
Cool. Do you have a favorite video that you've ever made?
Ooh, that's a good question. Yes. I think because I like this one because it was one of my turning points in understanding how to better communicate science to the general public. For a long time, I was posting videos that were very technically titled. I would post videos about foraminifera, these tiny, shelled organisms in the ocean, and I would call it foraminifera, not tiny shelled organisms in the ocean. And I did that because the videos, I tend to be pretty technical in the videos, so I didn't want to mislead somebody that thought, oh, I can follow this, and then get into the video and then they leave. But then I realized that there's a lot of people out there that really do want to see and hear about the details and this in-depth conversation if you can present it in a way that, you start from the beginning and bring them into that conversation. So I started titling them more inclusively, more to the broader public. And my favorite video where I really started doing that it's called When Earth Was Purple. And I had actually made that video before. It's about when early on Earth, there were these very first photosynthesizers that instead of green chlorophyll pigment, they might have had purple pigments. So they looked purple instead of green. And so Earth might have had a more purple hue instead of a green hue. And so I called it When Earth Was Purple. And that video did much better than when I had previously tried to do it called Early Photosynthesizers. So I realized kind of this power of bringing a lot more people in to learning about the science. And I also got a lot of comments on that video that was like, wow, I never would have known any of this. It was really cool to see that people came in that may not have clicked on the Early Photosynthesizers video, but did end up liking that topic when it was titled in a more inclusive, broad way.
Yeah, people are really smart and really curious, and the challenge is how to engage that curiosity. It sounds like you've been successful in doing so. Are you ever surprised by what videos connect with your audience, or do you feel like you have a sense when you're putting them out whether or not it's going to be a good one? Every
Week, I feel like I have a new sense of what to expect with what's going to vibe with my audience. But they always surprise me, I have a lot of videos on, isotopes, which people don't tend to care much about chemistry, very detailed chemistry like isotopes. But I had a video do really well about isotopes not too long ago, and I was very surprised and delighted that people were interested. So every week I learn new things that people want to know about, and it really opens my eyes to, wow, people are really curious. And if we can just work on our storytelling and our ways of communicating these things to people to make it more understandable and less jargon heavy and really bring them into the conversation, it can lead to a lot of really exciting new conversations after the fact. So that has been really, really surprising. I feel like every week I'm surprised with that.
Awesome. Thanks so much for sharing.
Thank you so much for having me.
In the UAE, this is what we do. We do it the Emirati way. Hard is more interesting. We don't have the luxury of time. We want to develop our capabilities as soon as possible and as fast as possible. So every mission has to be harder, has to challenge us more.
So the Emirates mission to the asteroid belt is a very unique mission. We're exploring 7 asteroids in the main belt, flying by 6 and rendezvousing with the 7th asteroid. No other mission has done a tour of this sort of the main belt. Emirates mission to the asteroid belt is mainly targeting main belt asteroids because it provides historic context for the formation of the solar system.
The MBR Explorer is equipped with advanced technologies. So the UAE is really pushing the boundaries and advancing the technologies that will enable us to even explore beyond the main asteroid belt.
This mission will host technologies never used before, and this reflects how the UAE is committed towards advancing the space exploration.
The theme of AGU 24 is What's Next for Science, inspiring attendees to envision the future of their fields. So we asked attendees, what's your next for science?
Next in my field, I think we're hoping to combine marine geology with terrestrial geology, find new ways to understand how ice sheets are changing through time and have changed in the past.
Yeah, so I'm really interested in AI and space travel. So I'm really excited to see how AI accelerates our process of finding where we're going to go to space beyond the Artemis missions to Mars.
What's next for science is connecting my community, which is in El Paso, Texas, a border city, to all of this magical world of AGU and all the other big conferences in geology.
I think engaging communities utilizing open source IoT technologies, low-cost technologies, so that communities can engage with climate science and weather science using their own sensors.
Oh, for my field, so I want to do computer engineering or computer science, and I feel like with all these AI platforms like ChatGPT and all those, a lot of people see it as it's not great, but I think that these platforms are going to benefit humanity and just help our future become more advanced in the long run.
I want to be an astronaut, and so the field that is most interesting to me is astronomy. So when I think about what's next for science for me, I think about what advances science, how can we uncover the histories of science.
I would say combating disinformation and restoring faith and trust in science.
So what is your next for science?
The Consortium for Advanced Data Simulation Research and Education, CATE, is founded by NOAA. CATE's goal is to advance data simulation research and workforce development and help NOAA improve their technologies for weather forecast.
This consortium includes 6 universities: the University of Oklahoma, who's leading the effort, Colorado State University, Howard University, the University of Maryland, and Pennsylvania State University, and the University of Utah.
CADRE is leveraging both artificial intelligence, new observation platforms, cutting-edge mathematics in order to push boundaries in data simulation science.
Every CADRE research project is centered on the graduate student and the training of the graduate student. During the research program, they'll be working directly with NOAA scientists, and so they will be able to see, as they're doing the work, how their research is actually going to change operational forecasting.
The main objective of ACTRIS is to support science that provides knowledge on atmospheric sciences, climate change, and other topics related to the climate.
ACTRIS data are open for everyone and can be downloaded worldwide.
In the next period, what I see as biggest impact is for sure a better understanding of the processing linking all these quantities, so aerosol, cloud, and trace gases. And in this sense, artificial intelligence will be key for taking the most from this large data set of information that we are collecting already since 2000.
ACTRIS will have a pivotal role in addressing the grand challenges like climate change, air quality, and public health in future.
The history of environmental disparities has mobilized activists in Atlanta because community members have felt left out of decision-making.
Seesaw is a learning ecosystem that is trying to answer how can geosciences learn from, contribute to, and work with communities that are facing fundamental problems to Earth systems. Really what we're trying to do is correct these historical injustices that higher education institutions have perpetuated against communities.
Seesaw, they have been extremely open and forthcoming with their ability to collect information in a way that we are not able to, and to share that information.
The students that are matriculating through Seesaw are gathering the skills, the attitudes, the perspectives of doing this on-the-ground work with the community. We're doing this work in the context of the people and the populations that we're geared towards helping.
You can catch the latest episode of AGU TV at the Walter E. Washington Convention Center, in your hotel room at the Marriott Marquis DC on Channel 42, on the AGU 24 meeting website, on the AGU 24 mobile app, and of course on all our social media platforms. And while you're there, make sure to subscribe to stay up to date on all of our geophysical content. We've explored the inspiring intersection of art and science, uncovering how creativity elevates discovery and transforms communication in the geosciences. And with that, we bring AGU TV and AGU 24 to a close here in Washington, D.C. Thank you for joining us throughout this incredible journey of innovation, collaboration, and exploration. We'll see you next year in New Orleans for AGU 25, where we'll continue to pioneer the Earth and space sciences. Until then, keep creating, discovering, and sharing. We'll see you next year.